In this topic, we'll talk about upgrading multiple versions of our production database. Now, whenever we produce software that's deployed to multiple databases or for multiple customers, there's always a chances that our databases will change at different rates. Some customers may upgrade at different schedules. Maybe some drift occurs in one, it doesn't occur in the other. What we really end up with is multiple versions of our databases and multiple versions of our application over time. The simplest method of upgrading all the databases is to try to get them all to the next version before we deploy the future version. We want to be careful of that, but it's not always possible. In the SQL Server world, Microsoft certainly doesn't get all their customers to SQL Server 2016 before they release 2017, so they have to plan for that. In the DevOps world, we may have to do that with our software as well. Some customers, some applications, some parts of the system will move slower or faster than others, and so we have to ensure our deployments match that up. For example, now our developers might prefer that our customers move from version 1.4 to 1.5 to 1.6 to 2. That's how they develop the software. That's the flow of development. But some customers will want to go from version 1.4 to 2 when the new software is released. Some will want to go from 1.4 to 1.5. So we may end up spending a lot of time testing different upgrade scenarios. And that's one of the reasons why vendors often impose limits on the number of previous versions they support for upgrades. It's too complex and too difficult to test all the different permutations of upgrades. For application software, the upgrades are simple, right? They typically just change their code. But when there's a linkage to the database, that's what usually causes problems for applications, and it certainly causes problems for database developers. Now, there could be dependencies of web services and other platforms that cause application issues, but typically, the database is often the bottleneck. And as we've discussed in this course, the database has to maintain state. We have to transition from one state to another one. Every time we do that involves risk, and certainly involves complexity when we're changing many objects. Now, we've discussed two methods of performing database development, state-based and migration-based development. And when we're looking to upgrade from an old version of a database to a new one, whether they're the same type of database or whether they're different customers of the same customer, doesn't matter. The easiest and safest method is to use a migration-based development strategy. Now, we're tracking all the scripts we run in development, so we know which have been executed against each database. So at any point in time, we could take the full set of scripts and apply it to any database and upgrade it to the latest version. Doesn't matter what version we start at, we can easily move it. Now, certainly, as we've discussed in previous lessons, all the caveats and disadvantages of migration-based development apply. But this does provide a simple upgrade path across the entire lifetime of the database. If you must work in an environment where you support multiple different databases and different versions, and you're never sure which version is on which system, migration-based development might be the best choice for managing your upgrades for different clients. It's certainly the easiest for developers, and it provides me the most options. The most important task for your development team is to ensure that each release is tagged so they know if they're going to allow the upgrade for migration scripts, they know where to stop that upgrade as well, how many migration scripts I need to actually run. If you're working a state-based development model, it's a little more complex. You can certainly implement deploy time comparisons so that at deployment time you actually look at the customer database, the current state of your code, and then generate a script. Assuming that you don't have any complex transformations and they can be worked out by your tool, that works fine. The potential issues of this approach are that whenever you detect these changes and build your script, you're depending on your transformation in the tool to work correctly. You've never tested what's going to happen, and so that's a risky item. If you have pre-post scripts in the state-based world, then you also depend on ensuring the correct versions of those scripts actually are being applied to the correct different versions of the database. In this case, state-based comparison may not work correctly. It is certainly a riskier path to upgrade your databases. At the end of the day, you hope that no data is lost and your upgrade either fails gracefully or it rolls back. That's the best case. In the worst case, you might need to do a restore, in which case you should always ensure that there's a backup process when you're working with multiple databases, because that may be your last resort to ensure that everything works correctly. DevOps helps you respond and manage issues. It helps you to work quickly, but a small number of customers with problems could easily overwhelm many development teams because of the diverse nature of all these different databases. If you must use state-based development, then be really careful about allowing any non-trivial transformations during development. You want to be careful about renaming objects and splits and merges, and you may choose to just live with those particular objects in the state they are rather than allow changes. Or you may choose to limit changes to major versions and then ensure that your customers are actually upgrading to a major version before they can move to the next one. There are some platforms in the database world that support schema versions, and in those cases, you may be able to deploy different versions of the schema to upgrade different customers to one version of the next, and then migrate them through schemas rather than having to work with the various different states that are there. In any case, dealing with multiple customer databases is certainly a complex scenario. Whether you choose migration-based or state-based, there are certainly solutions in a DevOps world. You'll have to pick what works best for your particular environment.